Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0A11, indicates a malfunction in the DC-DC converter activation circuit of the 2016 to 2022 Honda Pilot. This code suggests that the electrical system designed to convert direct current, DC, from the vehicle's high-voltage battery to the lower voltage used by various components has encountered an issue. The DC-DC converter is essential for powering various vehicle systems, including the related powertrain control module, PCM, ensuring vehicle operations run smoothly. Its location near the high-voltage battery is crucial for it to perform its role effectively. If this circuit malfunctions, it can lead to power supply issues, potentially affecting the vehicle's performance and features. A comprehensive understanding of the fault is critical for diagnosing and resolving the problem. Thus, following a systematic troubleshooting approach is imperative. The DC-DC converter is a vital component responsible for converting high-voltage DC power from the vehicle's battery into lower voltage DC power used by various electrical systems in the Honda Pilot. If there's a malfunction in this system, it can lead to insufficient power delivery to essential components. The DC-DC converter is typically located near the vehicle's high-voltage battery, enabling it to draw power efficiently. The failure of this converter may trigger DTC P0A11, indicating the activation circuit has problems that warrant detailed inspection. The role of the PCM, or Powertrain Control Module, is to manage these functionalities and ensure all components operate cohesively. A thorough understanding of this circuit structure helps diagnose issues effectively. Several factors can lead to the activation circuit malfunctions, indicated by DTC P0A11. One primary cause could be a faulty DC-DC converter itself, which may need to be replaced if it isn't functioning properly. Another potential issue is an open circuit in the control signal transmission, CST line, which can prevent the proper signal flow between the PCM and the converter, resulting in communication issues. Additionally, the presence of a short circuit to power can create erratic behavior in the system, leading to intermittent faults. Each of these causes necessitates a distinct approach to troubleshooting and repair to restore proper functionality. Attention to these areas during diagnostics is critical for effective resolution. Drivers may experience various symptoms when the DTC P0A11 is active, suggesting a malfunction in the DC-DC converter system. One common symptom is the illumination of warning lights on the dashboard, indicating the vehicle's diagnostic system has detected an issue. Additionally, a noticeable power loss to essential components can occur, affecting vehicle performance, particularly electronic systems dependent on the converter's output. The vehicle may also exhibit faulty performance during idle conditions, such as the auto-idle stop functionality not operating as intended. These symptoms not only place demands on diagnostics, but also emphasize the importance of addressing DTC P0A11 promptly to ensure vehicle safety and performance. The first step in troubleshooting DTC P0A11 involves verifying the problem with the vehicle in on mode. Begin by turning the ignition key to the on position. This is crucial for activating the onboard systems responsible for diagnostics. Using the Honda Diagnostic System, HDS, clear the DTC to reset the vehicle system and eliminate any false positives that may have occurred previously. After clearing the DTC, test drive the vehicle while ensuring that the auto-idle stop system operates effectively. This ensures that any issues manifest during normal operating conditions can be monitored closely. After the test drive, utilizing the HDS to check for any confirmed or pending DTCs will help solidify whether the fault is present. If the code reappears, it confirms a persistent problem that warrants further investigation. In this step, you will determine the possible failure area associated with the DTC P0A11. Begin by turning the vehicle off and ensuring that the systems are inactive to avoid any disruptions during testing. Using the HDS, jump the SCS line, which stands for the Security Control Service, and wait for more than 1 minute. This process helps to reset any skewed signals that may affect diagnostics. Next, disconnect the PCM connector A, which houses crucial connectors for the powertrain control module. Now, with the vehicle in the on mode, measure the voltage between designated test points, PCM connector A's pin number 2, and a solid body ground. If you find battery voltage here, it indicates that the PCM is functioning correctly, and the next troubleshooting step can be initiated. Conversely, if no voltage is detected, it points toward a possible issue in the signal flow, requiring further inspection. To further diagnose the issue with DTC P0A11, you'll perform an open wire check. Begin by ensuring the vehicle is turned off to isolate the electrical systems. Disconnect the DC-DC converter connector A and ensure it is removed from the circuit to facilitate accurate testing. You will then check for continuity between designated test points, specifically between pin number 2 of the DC-DC converter connector and pin number 2 of the PCM connector A. This test checks for an unbroken circuit along the CST line, ensuring that electrical signals can travel unhindered. If continuity is confirmed, it indicates that the wiring is intact, and the focus should shift to the DC-DC converter for possible replacement. Conversely, if continuity is absent, it suggests an open circuit exists in the wiring, necessitating repairs to restore functionality on this line. In the final step of troubleshooting DTC P0A11, you will conduct a shorted wire check. Start by turning the vehicle to the off position to ensure all systems are turned off. Then, disconnect the DC-DC converter connector A once more to isolate it from the circuit completely. Once disconnected, turn the vehicle to the on mode and measure the voltage between specific test points. Pin number 2 of the DC-DC converter connector and the body ground. This test is key to identifying any shorts to power within the circuit. If voltage is present, it signifies a short circuit in the wire leading between the PCM and the DC-DC converter, warranting immediate repairs or replacements as necessary. If no voltage is present, this suggests that the wiring in the CST line is intact, and further action would involve substituting a known good PCM to ascertain which component is at fault. Whether it be the PCM or the DC-DC converter itself, upon completing repairs related to DTC P0A11, it is essential to verify that the corrective actions taken have resolved the underlying issue. Start by utilizing the Honda Diagnostic System, HDS, to confirm that the repairs conducted have eliminated the DTC. Monitoring the system post-repair will help ensure that the DC-DC converter functions effectively without triggering any further error codes. It is crucial to conduct a test drive to observe the converter's performance under normal operating conditions, ensuring that all associated systems operate as intended. Additionally, keep an eye out for any reoccurrence of DTC P0A11 to rule out intermittent concerns. This verification process is vital to ensure long-term reliability and performance of the vehicle's electrical systems. Preventive maintenance is crucial in ensuring the longevity and optimal performance of the DC-DC converter and related systems in the Honda Pilot. Regular inspections of electrical connectors can identify potential issues such as corrosion or loose connections, that might lead to DTC codes in the future. It's also recommended to monitor battery voltage levels regularly to ensure they're within the operational limits, as discrepancies can signal underlying issues. Should any wiring deviations or insulation wear be detected during routine checks, addressing these swiftly will prevent larger problems from developing. Regular maintenance not only aids in early detection of faults, but also extends the overall lifespan of components, ensuring that your vehicle continues to operate at peak performance. In summary, DTC P0A11 points to a malfunction within the DC-DC converter activation circuit, a vital component responsible for supplying power to lower voltage systems in the Honda Pilot. A methodical approach to troubleshooting is essential to ensure all potential issues are addressed, from confirming voltage levels to checking for continuity or shorts in the wiring. Understanding the systems involved and following the outlined procedures will facilitate accurate diagnostics and effective repairs. Furthermore, implementing preventive maintenance measures will greatly enhance the longevity and reliability of these electrical systems, reducing the likelihood of such DTCs arising in the future. Staying proactive will not only ensure improved vehicle performance, but also result in a better driving experience over time. Please like and subscribe to the channel. See you next time!